Hello everyone. Welcome to the video lecture series of Z Transform. I am Professor Mayur Gohil. In this video lecture series, I shall be dealing a very special topic called negative binomial expansion. Let me discuss it over here. If we have a positive integer n and mod x is less than 1, then we have this formula. What does this formula say? 1 upon 1 plus x whole raised to n is equals to 1 minus nx plus minus of n into minus of n minus 1 into x square plus minus of n into minus of n minus 1 minus n minus 2 over 3 factorial into x cube plus so on the pattern follows. So you have to multiply minus n minus 1 minus n minus 2 minus n minus 3. So such four terms are there, so you divide by 4 factorial and then there is x raised to 4. This pattern continues, it goes on. Now what is more important about this is basically the binomial expansion, the negative binomial expansion over here. So this is the formula. Okay, so this is the formula for negative binomial expansion. Let us understand this in much detail. So what happens basically in the first step, you see 1 minus nx, that is okay. Then there is minus n and there is minus n plus minus n. So let us understand. So let us understand this in detail. In the first step there is 1, not a problem. In the second step there is minus nx, that's also okay. In the third part over here, in the coefficient of x square, what do we see? There is minus n, there is minus n minus 1. So we can take those minus common and multiply together, so the entire coefficient becomes positive. The next, when you see there are three minuses coming outside, so there is minus from the first term, minus n minus 1, and there is minus n minus 2. So there are three minuses, so basically the coefficient is going to have a minus sign over here, so I have written that minus 1 over here. So what do I observe? Like each time when there is an even power, I will have the coefficient to be positive, and when there is an odd power, right, x raised to 3, x raised to 5, I will have a negative coefficient of x powers of x will have negative coefficient when the power is odd, and it will have a positive coefficient when the power is even. So on this basis, this gets simplified to a combinatorial notation. So the combinatorial notation, this is n plus k minus 1 choose k into minus 1 raised to k into x raised to k, where k goes from 0 to infinity. This is the simplified version of this entire expansion. Okay, you can also write this in this manner. If you are not familiar with this combinatorial notation, you can write in this way also. You can write n plus k minus 1 choose k minus 1 whole raised to k into x raised to k, or it is also written in some books in this manner: summation c n plus k minus 1 comma k minus 1 to the power k into x raised to k, where k goes from 0 to infinity. This is one alternate way of writing the combinatorial notations or the combinatorial coefficients. So This was negative binomial expansion. I'll give you the general form of this here. The general form is this way. If you have a plus x whole raised to minus n, then the negative binomial expansion looks something like this. It is just like the regular binomial expansion, but instead of n choose k, you have minus n choose k. Okay, so that minus n choose k is now further on simplification becomes n plus k minus 1 choose k times minus 1 to the power k. That is the equivalence of the coefficient over there. Okay, and this expansion is valid when mod x is less than a. Okay, so this is one another simplified version of the negative binomial expansion. I hope you remember this expansion. This is a very non-trivial expansion. It is not used largely in day-to-day problems, but this is very, very important in computer sciences as well as coding and other expansions when we are concerned, as well as in z transform. So this is very crucial, one of the formulas over there. So we are seeing this. So I hope you like this short video on negative binomial expansion. Please hit like, subscribe to my channel, and share this video with your friends, those who find it useful. Thank you. I shall soon see you in the next topic of z transform.